Hi everyone, I am Ian Chaoyang. It is my pleasure to introduce our work on viewpoint adaptation for semantic segmentation, where the distributional shift caused by viewpoint change makes domain alignment fail in learning transferable mappings. Let me be more specific of the problem. Nowadays, we have many multi-camera systems, as observed in AR/VR equipment and assistive robots. It is crucial for them to have accurate sensing across cameras to form a comprehensive understanding of the scene. However, human annotation may only be abundant for one view. Our goal is then to generalize human labels from label-rich viewpoint to another with little annotation. The difficulty is that the images captured from multiple viewing angles now differ many in the spatial structure of the semantic content, which is equivalent to viewpoint. Thus, an alignment that learns away viewpoint will result in invariant features which are not adequate for scene parsing. So how can we transfer labels across viewpoints while avoiding harmful alignment of the domains? Instead of domain alignment, we ask whether we can hallucinate the semantic labels for the unlabeled target using that from the source view. An intuitive idea is to first reconstruct the 3D geometry of the scene using the source and target images. Then, with a few 2D, 3D projections, we could obtain the target labels. However, this pipeline involves multiple components, for example, camera localization, multi-view stereo, and fusion, after which we still have to perform label hallucination for occlusions. Another option is to train a view synthesis network on the RGB images, and then apply it on the source view semantic labels. Yet, due to the distributional shift between the image and the semantic labels, the hallucinated label can be quite off. To resolve these issues, we pick the point in between. We assume no camera parameters and still keep the benefits that geometry can bring. In a nutshell, we achieve this by proposing a novel view transformation network that handles label transport and occlusion hallucination within the same architecture. The key is an information transport inductive bias injected into the network's feature space. After training on the RGB images, we can apply it on the source view semantic labels, which then use much better hallucinated labels for the target domain. With uncertainty incorporated using a functional decoding strategy, the hallucinated labels can be used to improve the performance for the target view. To see whether the information transport works as desired, we can trace the attended region in the source view that is used for synthesizing the target view. These traces show clearly that information from semantically corresponding regions are used during hallucination, even for occluded regions. We compare with different types of methods on various target domains generated by changing the viewing angles. Our evaluation shows that ineffective transfer is prevailing in unsupervised domain adaptation methods that rely on domain alignment, which verifies our conjecture. Also, explicit correspondence-based methods do not perform well when the viewpoint change is large, due to inaccurate matching and their incapability to deal with occlusions. Again, view synthesis methods fail as small view changes, given the statistical discrepancy between RGB image and semantic labels. Our method consistently achieves the top domain adaptation gains by utilizing the information transport inductive bias in the view transformation architecture. Thanks for your attention. Our code and datasets are publicly available. Please check our poster for more technical details.